Hello, my name is Zachary Miner, and I am here to talk about moles. Now, I understand that at first, you would think about the little guys that dig underground. We are not here to talk about those guys, however. We are here to talk about the number that was simply recognized as mole. Specifically, this number is 6.02 times 10 to the 23rd power. Now, the mole was originally named after the early 19th century Italian scientist that discovered the mole, Amedeo Avogadro. The number was named in his honor until then as Avogadro's number and Avogadro constant. Now, it has been used in various ways, but before we get to it, I should tell you that 6.02 is a big number. Namely, it is 602 with 21 zeros right after it. So it's a big number. It is used to determine the amount of mass or the number of atoms in a given compound. A compound is a combination of atoms from different elements. One such example is water. Now, the use of the mole is like a racetrack. One just has to find the starting line and start moving forward, really. Now, take for example, you have 1 mole of a given compound and you want to know the mass of said compound. To do this, you multiply the number of moles by the total atomic weight of the elements in the compound. Like, let's take water. Say you got 1 mole of water, which specifically is H2O, and you want to know the number of grams. You multiply 2 by the atomic weight of hydrogen, which specifically is 1.0079, and you should get 2.0158. You then add the atomic weight of oxygen, which is 15.999. You should have 18.148 grams. Now we'll be talking about atoms. Now, the interesting thing with atoms in a mole is that you don't really talk about the number of atoms specifically, but rather the number of moles of atoms. Really, I understand that it would be weird to say that there are moles within a mole, but rather it's the moles of the atoms specifically, and not the compound itself. To find the number of moles of the atoms, you multiply the number of moles, let's say 1, by the number of atoms involved in the chemical formula, divided by the total atomic weight of the elements in the compound. Imagine you got 1 mole of H2O, and might I remind you that it is water, and you want to find the number of moles of atoms in that mole. You multiply the number of moles of the compound, 1, by the number of atoms involved in the chemical formula, in this case 3, as with 2 hydrogen atoms and 1 oxygen atom, 2 plus 1 equals 3, and then divide that by the total atomic weight of the elements in said compound. Might I remind you that we are using the same number, 18.0148. The equation should look like the one shown. The answer should be relatively very close to 0.16653. Now, the mole's popularity often originates, well, popularity among scientists and chemists anyway, is because it allows them to easily count atoms in a lab, mainly because atoms are so small. So small that in fact that we can barely see them. It's used internationally because it allows chemists to speak the same measurement. Really, it's very quite useful. It's often used as, it's always used in labs, everywhere.